Welcome to the next lesson in this chapter, which could end up being the most interesting lesson of this chapter because we're going to implement asynchronous communication between our modules using messaging. Instead of having our modules call each other's public APIs in a request-response fashion and also introducing temporal coupling, we could refactor this to a completely asynchronous approach and use messages to communicate between our modules. The exact term that I'm going to use for this type of message is an integration event. We already talked about domain events in a previous lesson, and domain events are appropriate to trigger side effects inside of a single bounded context, and in our case, inside of a single module. But if we want to cross the module boundary, we need to use integration events. And in this case, integration events are going to become the public API of our modules. When it comes to implementation details, I will be using mass transit to implement messaging between our modules, and we're going to start off with the in-memory transport or the in-memory message broker because I think it's sufficient inside of a monolith. There is a downside to using this approach, which is the potential risk of losing messages that we are going to mitigate in a future chapter when I'm going to talk about reliable messaging. But for now, let's start publishing integration events using mass transit. This is where we left off in the previous lesson, where we added a domain event handler for the user registered domain event. In the handle method, we were calling the ticketing API to create a customer record, effectively duplicating the user from the users module into a customer from the ticketing module. However, this is still synchronous communication between our modules, even though we are doing this inside of a domain event handler. So now I want to show you how we can move this to a completely asynchronous approach by introducing integration events and leveraging mass transit for sending messages. So we're going to start by creating a few abstractions that will be necessary. Inside of the common application project, I'm going to add a new folder called Event Bus. And inside of this folder, I'm going to introduce a new interface that I will call the iIntegration event. This interface is going to have two properties, an identifier for the integration event and a datetime property for when the integration event occurred. I'm also going to create a default implementation of my integration event type. So let's create a public abstract class called integration event. It's going to implement our interface, and I'm going to add init setters for the two properties, as well as a default constructor that's going to set these properties values. Let's also initialize the other property from the constructor, and this will be sufficient for the base integration event type. Then another component that we are going to need is an event bus that we will use to publish our messages. So let's create an iEvent bus interface. This interface is going to have just one asynchronous method. This is going to be called publish async, and it's going to publish a generic type. Let's call this generic type the integration event. It's also going to need a cancellation token, and I'm going to add a generic constraint that our generic argument has to be an iIntegration event. We could also force it to be a class implementing iIntegration event if we want to be more specific. However, just leaving the interface in the generic argument is going to be sufficient. The next thing we need is an implementation of this interface, and this falls under cross-cutting concerns, so I'm going to implement it in the common infrastructure project. Let me create an event bus folder, and I'm going to add a new class inside that I will call the event bus. This is going to be an internal and sealed type, and it's going to implement our event bus interface. Let's implement the missing members, and then we need to figure out how we are going to publish our messages. And I already revealed the answer in the introduction. We will be using mass transit. This is an amazing library for implementing distributed messaging in .NET, and I highly recommend it. So let's go ahead and install the latest version. Now back to our event bus implementation. I'm going to use the iBus interface from mass transit to publish my message, and once I have my bus, the implementation becomes straightforward. All I have to do is say await bus publish, and I need to specify my integration event and the cancellation token. So the publishing side is taken care of. Let's also register this with dependency injection. I'm going to register the event bus as a singleton by calling try add singleton, and then let's add the event bus interface and the event bus implementation. The next thing I need is to register mass transit. So I'm going to say add mass transit. And now we need to configure mass transit with dependency injection and set a few things up. So first of all, let's use the memory transport for publishing our messages. And I'm going to provide a delegate to configure the in-memory transport. And what I want to do here is call the configure endpoints method and pass in my context, and this will pick up my message consumers and register the required broker topology. Then I'm going to say set kebab case endpoint name formatter because I think this makes our endpoints nicely readable. And then the next thing we would need to do, although I'm just mentioning this for later, is add our message consumers. We have to do this from the mass transit configuration, but the problem that we will run into is that our consumers are not going to be defined inside of this assembly. So I'm going to show you how we can solve this in just a moment. For now, let's leave the mass transit implementation like this. So let's close down the types that we no longer need, and let's focus on the user registered domain event handler. Instead of calling the ticketing API here, what I want to do is to publish an appropriate integration event. So let's head over to our users module, and I'm going to get rid of the public API project entirely because I will no longer be using it. I also have to fix the service registration in my users module. So let's get rid of that. Now I'm going to add a new project to my users module, which is going to become my new public API. And I will call this Evently Modules Users Integration Events. As I said, this will become the new public API of my module. And let's clean up the project file. Now let's repurpose this class to become our first integration event. And let's call this the user registered integration event. This is going to be a sealed type, and we're going to implement the integration event base class, which means I will need to add a reference to the common application project so that I can see this type. So let's specify integration event, and then this requires a constructor accepting an ID and a datetime object when this integration event occurred. And you're going to see that it will be really interesting how we initialize this value. Then I'm going to need a user ID property and a few string properties for the other values of our user. So let's say string email and then string first name, and then I'm going to say string last name. Now let's initialize all of these values from our constructor, and I'm going to adjust the constructor slightly so that all of this is formatted vertically. The next thing we need to do is to actually publish our integration event. So let's add a reference to the integration event project from our application project. We are going to reference Evently Modules Users Integration Events. And now in the user registered integration event handler, instead of using the ticketing API, I'm going to replace this with the iEventBus interface. And down below, instead of calling the ticketing API, I'm going to say publish async. We need to specify the integration event that we're going to publish, and this will be the user registered integration event. And now let's specify the required arguments for this constructor. The identifier and the occurred on value will come from our domain event. So I can access notification ID and notification occurred on. The other values I will specify from the result that we get back as the result of the query, and then I can also specify the cancellation token. And when I format this properly, you can see how we have updated our user registered domain event handler. I'm also going to update this project to remove the reference to the public API of the ticketing module, which I will be deleting anyway as part of this lesson, but I want to comment on the fundamental difference of this implementation of the user registered domain event handler. In this case, instead of calling the public API in a request response fashion or synchronously, we're going to asynchronously publish an integration event to the message bus. In the initial implementation, this is going to be an in-memory message bus, but we can always replace this with a proper distributed messaging system. And now the next thing we need after publishing our integration event is to consume it inside of the ticketing module. Now, I consider this to be an input into the system, which is part of my presentation layer. So let's create a folder here called customers. And inside of it, I'm going to add a new class that's going to be the user registered integration event consumer. This type is going to implement the iConsumer interface from Mass Transit. And because we don't have a reference to Mass Transit, we can install the Mass Transit abstractions library. So I'm going to go ahead and do this. However, I will also make an update in my project file and move this NuGet package into the common presentation project so that it's available to our other modules. So let's say right under here, after the frame